Chemical properties of alkaline earth metal. Chemical properties of alkaline earth metals. Okay. Oxidation state. First is oxidation state. Alkaline earth metals show fixed oxidation state of +2, +1. Oxidation state is unstable +3. Oxidation state cannot be found due to very high value of ionization potential third. Hence, all are divalents. Okay. Alkaline earth metals. Alkaline earth metals. Alkaline earth metals show fixed oxidation state. So fixed oxidation state. So fixed oxidation state. Okay. So fixed oxidation state of +2, +1. Okay. Oxidation state is unstable. Oxidation state is unstable. Oxidation state is unstable. +3 oxidation state cannot be formed. +3 oxidation state cannot be formed. Oxidation state cannot be formed. Okay. Oxidation state is cannot be formed due to very high value of third ionization potential. Hence all are divalent. Divalent. Okay. Second point. Activity. The metals are very reactive and form compound with non-metals. Okay. The metals are very reactive. The metals are very reactive and form compounds with non-metals and form compounds with non-metals. Okay. On account of low ionization energy. On account of low ionization energies. On account of low ionization energies, these are highly reactive. These are highly reactive. Okay. These are highly reactive. However, these are less reactive than alkali metals. However, these are less reactive. These are less reactive than alkali metals. Okay. The metals are very reactive and form compound with non-metals. On account of low ionization energy, these are highly reactive. However, these are less reactive than alkali metals. Third point. Action with water. Okay. Action with water. alkaline earth metal except beryllium react with water, liberating hydrogen gas. Reactivity increases and moving down the group. Okay, Mg plus H2O hot water. Okay, H2O hot water after reaction MgO magnesium oxide plus hydrogen. Magnesium oxide plus hydrogen. Okay, calcium plus water H2O after reaction calcium hydroxide. Okay, plus H2 gas plus H2 gas. Okay, alkaline earth metals react with water, liberating hydrogen gas. Liberating hydrogen gas. Reactivity increases and moving down the group. Reactivity increases on moving down. Reactivity increases on moving down. Reactivity increases on moving down the group. Moving down the group. Okay. Okay. And next point is fourth point. Action of air or oxygen. Action of air or oxygen. Action of air or oxygen. Okay. Action of air or oxygen. The surface of alkaline earth metals are tarnished when exposed to air or oxygen. This is due to formation of oxide layer. Okay, this is due to formation of oxide layer. The burn when heated in air to form their oxide. Okay, as example, M plus half O2. That is after burning metal oxide with all but beryllium. Okay, M plus O2. That is metal dioxide MO2 with barium. Okay, with barium and calcium 2Ca plus O2. That is 2CaO, calcium oxide. Okay, strontium plus oxygen and after reaction 2 strontium oxide. 32 strontium. Okay, after for balancing reaction. Okay, and barium plus O2 oxygen. That is barium oxide. Okay, peroxide. Barium peroxide. That is peroxide. Barium peroxide. Okay, that is barium peroxide. Calcium oxide and strontium oxide react exothermally with water, forming hydroxide. Okay, forming hydroxide. 1 minute. Calcium oxide plus strontium oxide. Okay, react exothermally with water. And forming hydroxide. Exothermally. Okay, calcium oxide and strontium oxide exothermally exothermally, and with water forming hydroxide, with water water and forming hydroxide, okay. Then calcium oxide plus water, that is calcium hydroxide, okay. Strontium oxide plus H2O, that is hydroxide strontium hydroxide, okay. The basic nature of oxides increases gradually from beryllium to barium, okay. The basic nature of oxide increases gradually from beryllium to barium, okay. The basic nature of oxides increases gradually from beryllium oxide to barium oxide, okay. That is beryllium oxide amphoteric, and magnesium oxide weakly alkaline, and calcium oxide alkaline, and strontium oxide and barium oxide, that is strongly alkene, okay. 5 point. Hydrides. On heating with hydrogen, all the metals from hydrides, when these hydrides are treated with water, they produce hydrogen and hydroxides, okay. On heating with hydrogen MH2, metal is heating with hydrogen, all metals form hydrides. When these hydrides are reacted with water, this produce hydrogen and hydroxide, that is M plus H2 MH2, that is except beryllium, and calcium plus hydrogen, that is CaH2, okay. BeH2 is prepared by the reducing of beryllium chloride with LiAlH4, okay. 2BeCl2 plus LiAlH4, that is 2BeH2 plus LiCl plus AlCl3, okay. All are white crystalline solids, liberate hydrogen gas with water. Thus the hydrides of this group metals behave as a reducing agents, okay. All are white crystalline all are white crystalline solids, and liberate hydrogen gas with water. Thus the hydrides of this group hydrides of this group metals metals behave metals behave as reducing agent, as a reducing agents. Okay. Calcium hydroxide CaH2 plus water H2O, that is CaOH, calcium hydroxide plus hydrogen gas, MgH2 plus 2H2O, that is MgOH whole twice plus 2H2. Okay. Beryllium hydride BeH2 and MgH2 are covalent in nature, while others are ionic in nature, while others are ionic. Others are ionic in nature. Okay. Next point, nitrites. Okay. 1 minute. Nitrites. Next are nitrites. Okay. Nitrites. All metals react with nitrogen and form nitrides, which decompose on heating. Okay. All the metals react with nitrogen and form nitride and form nitrides which decomposed on heating. 3m plus n2, that is delta m3 n2. 3mg plus n2 after heating mg3 n2. 3ca plus n2 after heating, that is ca3 n2. Okay. These nitrides react with water and produce ammonia gas. These nitrides react with water and produce ammonia gas and produce ammonia gas, that is M3N2 plus 6H2O, and after reaction 3MOH whole twice plus ammonia gas. Okay. Mg3N2 plus 6H2O, that is 3MgOH whole twice plus ammonia. NH3. Okay. The tendency to form nitride decreases from beryllium to radium. The tendency the tendency to form nitrite, the tendency to form nitrite, the tendency to form nitrite decreases from beryllium to radium. Okay, 1 minute. Next point. Carbides. 1 7 carbides. Magnesium to barium are their oxides give carbides with formula MC2 when heated with carbon. Okay. Magnesium to barium are their oxides. Magnesium to barium are their oxides. Their oxides gives carbides their oxides gives carbides with formula MC2 when heated with carbon. When heated with carbon. Okay, heated with carbon. Okay, Ca calcium oxide plus 3C, that is CaC2 plus CO, carbon monoxide. Okay, beryllium gives beryllium carbide are formula Be2C. Okay, and 2 barium monoxide plus 3 carbon, that is Be2C plus 2CO, carbon monoxide. Okay, that is beryllium carbide. Beryllium carbide. Okay, and the carbides of magnesium to barium give acetylene when react with water, while beryllium carbide gives methane gas. The carbides of magnesium to barium. The carbides of magnesium to barium. The carbides of magnesium to barium give acetylene when react with water. When react with water, while Be2C beryllium carbide gives methane gas. Okay, CaC2 plus 2H2O, that is CaOH whole twice plus C2H2 acetylene and Be2 plus 2H2O, that is 2BO plus CH4 methane, that is methane. Okay, next point highlights. Okay, next point highlights. Next point highlights, highlights. Next point, highlights. Next point, highlights. Next point, highlights. Okay, highlights. So metals react with halogens and form highlights with formula MX2 at high temperature. Okay, the metals react with halogens, react with halogens and form highlights form highlights with formula MX2 with formula MX2. Okay, at high temperature, at a high temperature, okay. Beryllium highlights are covalent while other are electrovalent in nature. Beryllium highlights, okay. Beryllium highlights are covalent. Beryllium highlights are covalent while beryllium highlights are covalent while other are electrovalent in nature. Electrovalent in nature. M plus X2, that is MX2, Be plus Cl2, that is BeCl2, Mg plus Br2, that is MgBr2, Ca plus Cl2, CaCl2. Okay. The metals react with halogens and form highlights with formula MX2 at high temperature. Beryllium highlights are covalent while other are electrovalent in nature. Okay. All highlights except fluorides are soluble in water. All highlights are highlights except fluoride. Fluorides are soluble in water. Water are soluble in water. The solubility of highlights, the solubility of highlights, except fluorides decreases and moving down the group. Decreases and moving down the group, and moving down the group. Okay. Next, hydroxides. 9 points. Hydroxide. Next point, hydroxides. Okay. Next point, hydroxides. Okay. So the hydroxides are obtained by reacting the oxides with water. Okay. MO plus H2O, that is MOH whole twice, that is M equal to calcium, strontium and barium. Calcium, strontium and barium. Okay. Calcium oxide plus water, that is calcium hydroxide, and strontium oxide plus water, that is strontium hydroxide and barium oxide plus water, that is barium hydroxide. Okay. The solubility of hydroxides increases on moving down the group. Beryllium hydroxide is covalent due to high polarizing power of small cations B plus 2, while barium hydroxide is an ionic compound. The solubility of the hydrides increases with increase in atomic numbers. 10 point. Point 10. Action with dilute acid. Action with dilute. Action with dilute acids. Dilute acids. Action with dilute acids. Okay. Action with dilute acids. All metals react with dilute acid and leave out hydrogen gas. Okay. All the metals react with dilute acid, dilute acids and liberate hydrogen gas. Okay. M plus 2HCl, that is MCl2 plus hydrogen gas. Okay. M plus H2SO4, that is MSO4 plus hydrogen gas. M plus 2HNO3. Okay. HNO3, that is MnO3 whole twice plus H2. Okay. As example, magnesium plus 2HCl hydrogen chloride, that is magnesium chloride, MgCl2 plus hydrogen gas. Ca plus H2SO4, that is CaSO4 plus H2 hydrogen gas, and Ca plus 2HNO3 ammonia HNO3. Okay. CaNO3 whole twice plus hydrogen gas. Okay. And beryllium reacts very slowly with dilute acid. The reactivity increases down the group due to gradually increase in electropositive character. Okay. Barium reacts very slowly with dilute acids. The reactivity increases. The reactivity increases down the group due to gradual increase in electropositive character. Gradually increase in electropositive positive character, electropositive character. Okay. Next point. Carbonates and bicarbonates. Carbonates and bicarbonates. Okay. Next point. Carbonates and bicarbonates. Okay. Carbonates and bicarbonates. 11 point. Carbonates and bicarbonates and bicarbonates. Carbonates and bicarbonates. Carbonates and bicarbonates. Carbonates and bicarbonates. Okay. The carbonates of alkaline earth metal are insoluble in water but soluble in acids. Okay. The carbonates of alkaline the carbonates of alkaline earth metals are insoluble in water but soluble in acids. Okay. The carbonates of alkaline earth metal are insoluble in water but soluble in acids. As example, magnesium carbonate MgCO3 plus HCl hydrogen chloride, that is MgCl2 magnesium chloride plus water plus carbon dioxide gas. And calcium carbonate plus HCl hydrogen chloride, that is CaCl2 calcium chloride plus water and plus carbon dioxide gas. Okay. Upon heating, these carbonates decompose and give metal oxide and carbon dioxide. The thermal stability of these carbonates increases with increase in atomic number. Okay. The thermal stability of these carbonates, the thermal stability of these carbonates the thermal stability of these carbonates increases with increase in atomic number. Increases with increase in atomic number. Increase in atomic number. Increase with atomic number. Okay. Increase with atomic number. Okay. Beryllium carbonate decomposed at beryllium carbonates BeCO3 decomposed at 400 degrees Celsius into BO beryllium oxide and carbon dioxide. Okay. That is BeCO3 at 400 degrees Celsius temperature, BeO plus CO2 and MgCO3 decomposed at 600 degrees Celsius into magnesium oxide and carbon dioxide. MgCO3 at 600 degrees Celsius, MgO magnesium oxide plus carbon dioxide. Similarly, calcium carbonate decomposed at 900 degrees Celsius into calcium oxide. Calcium oxide plus carbon dioxide. Okay, and carbonate, strontium carbonate, carbonate decomposed at 1100 degrees Celsius temperature into strontium oxides plus carbon dioxide. Strontium oxide plus carbon dioxide. But barium carbonate and radium carbonate do not decompose at a red hot condition. But barium carbonate, barium carbonate and radium carbonate barium carbonate and radium carbonate do not decompose at red hot condition. Okay, red hot condition bypassing carbon dioxide in excess in aqueous, bypassing MgCO3, and carbon dioxide in excess in aqueous suspension of these metals carbonates. They convert into bicarbonates. As example, magnesium carbonate plus water plus carbon dioxide gas excess, that is magnesium bicarbonates and calcium carbonate plus water, that is plus carbon dioxide excess in calcium bicarbonate. Okay, the bicarbonates of these metals are soluble in water, and upon heating they convert into their carbonates. And Mg, magnesium bicarbonates of these metals are soluble in water, and upon heating these convert into their carbonates. Okay, MgCO3 plus water plus carbon dioxide gas. Ca, calcium bicarbonate and soluble in water, and after heating converted into calcium carbonate plus water plus carbon dioxide gas. Okay, next is sulfates. 12 point sulfates. 12 point sulfates. Okay, 12 point sulfates. 12 point sulfates. All form sulfates of the type MsO4 into BeSO4 and MgSO4 and MgSO4, okay, are radially soluble in water. Calcium sulfate is slightly soluble, while strontium sulfate, barium sulfate, radium sulfates are insoluble in water. Thus, the solubility of the solvents decreases with increase in atomic number. Except barium and strontium, other metals soluble from crystalline hydrate. Okay, that is barium sulfate with hydrated 4H2O, that is magnesium sulfate and hydrated 7H2O, that is calcium sulfate hydrated 2H2O. Okay, 13 point. phosphides and sulfides. Phosphides and sulfides and sulfides. Phosphides and sulfides. Okay. The element of group second. The elements of group second. The elements of group second A when heated with phosphorus. When heated with phosphorus, heated with phosphorus P or sulfur S, they form their respective phosphides M3P2 and sulfides MS, that is 3Ca plus 2P, that is Ca3P2 and strontium plus S, that is SRS. Okay. 14 point. Complex formation. Okay. Complex formation. Due to small radius ionic potential, beryllium plus 2 magnesium plus 2 is small, hence this form better complex than rest at the members beryllium plus 2 magnesium plus 2 act as Lewis acids. Okay. Beryllium chloride plus 2 chlorine as BeCl4 minus 2. M plus 2 forms complexes with nitrogen and oxygen containing ligands. Complexes with oxygen ADTA and CH3COO negative are important complexes of M2 plus cations. Okay. Nature of compounds. 15. Nature of compounds. Okay. Nature of compounds. Okay. First, nature of compounds. Nature of compounds. Okay. First point. Acid base nature of compound and hydrolysis. Acid base nature. Acid base nature of compounds. Acid base nature of compounds and hydrolysis. Okay. Except for beryllium oxide, barium hydroxide, all oxides and hydroxides are basic. Beryllium oxide and beryllium hydroxide are M4. Okay. Beryllium oxide is beryllium chloride plus water. Okay. Beryllium oxide plus 2 sodium hydroxide, that is sodium beryllium oxide plus water, and magnesium oxide plus hydrogen chloride, that is magnesium chloride, MgCl2 plus H2O, and calcium oxide plus hydrochloric acid, that is after reaction calcium chloride plus water. Okay. Barium plus 2, that means cations, and magnesium cations, and magnesium cations. Salts are hydrolyzed but other are not hydrolyzed. Salts are hydrolyzed, but others, but others are not hydrolyzed, but others are not hydrolyzed. Okay. Be plus 2 plus H2O. That is Be plus 2 and oxygen double bond hydrogen that is BeOH plus H positive ions. Okay. Mg plus 2 plus H2O that is Mg plus 2 is oxygen hydrogen that is MgOH plus H positive ions. Okay. H positive ions. Okay. And covalent beryllium chloride and magnesium chloride are hydrolyzed due to unsaturation of maximum covalency and availability of empty p orbitals. Okay. Okay. The covalent of beryllium chloride and magnesium chloride are hydrolyzed due to unsaturated of maximum covalency and availability of empty p orbitals. BeCl2 plus H2O that is Cl, BeCl, BeOH, Cl plus HCl and that is oxygen, hydrogen and MgCl2 plus H2O, water, aromatic of chlorine, magnesium, that is oxygen, hydrogen and Cl that is MgOH, Cl plus HCl plus HCl. Okay. And due to low ionic potential, due to low ionic potential, mu equal to charge upon radius, Ca plus 2, Sr plus 2 and Ba plus 2 are not hydrolyzed, are not hydrolyzed, are not hydrolyzed. Charge density is low. Charge density is low. Charge density is low, and so these are unstable to pull low pair electrons of oxygen and water. Okay. And metallic character increases from beryllium to beryllium, and so basic character of metal oxide increases from beryllium oxide to beryllium oxide due to increase in size from B plus 2, Ba plus 2 and Ma plus 2 OH negative. Attraction decreases from beryllium hydroxide to barium hydroxide, and so dissociation of MOH to M plus 2H OH negative increases and basic character increases. Due to hydrolysis, solution are acidic. Basic strength is increases. Basic strength is increases from beryllium oxide, magnesium oxide, calcium oxide, potassium oxide, barium oxide. Okay. Basic strength, basic strength, basic strength, basic strength increases, increases, basic strength increases beryllium hydroxide, magnesium hydroxide, calcium hydroxide, calcium hydroxide, strontium hydroxide, barium hydroxides. Okay. Hydrolysis, hydrolysis, hydrolysis. Be plus 2 is greater than Mg plus 2 is greater than Ca plus 2. Magnetic properties, magnetic property. Second point, magnetic, magnetic property, magnetic property. Metals are their ions and compounds are diamagnetic. Metals and their ions, metals and their ions and compounds are diamagnetic, are diamagnetic, diamagnetic, diamagnetic. Third point, color of compounds, color of compounds, color of compounds, color of compounds. Okay. Compounds of M plus 2 alkaline earth metals, alkaline earth metals, alkaline earth metals are colorless, are colorless, colorless, are colorless. Okay. And all compounds of alkaline earth metals, fourth point, all compounds of alkaline earth metals on dissolving in water give Be plus 2, Mg plus 2, Ca plus 2, strontium plus 2 and beryllium plus 2 ions. Okay. All compounds of alkali earth metals, all compounds of alkaline earth metals, alkaline earth metals, all compounds of alkaline earth metals on dissolving in water, on dissolving in water, on dissolving in water and give Be plus 2, Mg plus 2, Ca plus 2, Sr plus 2 and barium plus 2 ions. Okay. Ions. Okay. Okay. And next point, only beryllium and magnesium form complexes. Only beryllium and magnesium form complexes. Okay. Only beryllium and magnesium form complexes. Okay. Only beryllium and magnesium form complexes. 6 point. Solubility of compounds. Solubility of compounds. Solubility of compounds. Okay. Compounds are soluble, springly soluble, and insoluble. Okay. Compounds are soluble. Compounds are soluble. Springly soluble, sparingly resoluble, sparingly soluble and insoluble, soluble and insoluble. Okay. And for example, calcium chloride is soluble, calcium sulfate is insoluble, and calcium hydroxide is less soluble. Solubility of hydroxide has the order of BeOH whole twice. Beryllium hydroxide is the less than magnesium hydroxide. Magnesium hydroxide is the less than calcium hydroxide is the less than strontium hydroxide is the less than beryllium hydroxide. Okay, this is the solubility of hydroxide has order. This is the solubility of hydroxides hydroxides has the order has the orders. And okay, and the solubility of sulfates has the orders. Beryllium sulfate is the greater than magnesium sulfate is the greater than calcium sulfate is the greater than strontium sulfate is the greater than barium sulfate. This is the solubility of sulfate has the order. Solubility of sulfate has the order. Okay. Next, the hydration energy of metals ions decreases from beryllium to barium due to increase in radius. From beryllium to barium, lattice energy of metal hydroxide also decreases from beryllium to barium, and due to increase in radius from beryllium to barium plus ions. Okay, the difference in lattice energy and hydration energy becomes less and less positive from beryllium hydroxide to barium hydroxide, and solubility increases from barium hydroxide to barium hydroxide. The decreases in lattice energy is more relative to the hydration energy from beryllium hydroxide to barium hydroxide. In the case of sulfate, due to large size of sulfate ions, lattice energy of all metal sulfate is nearly same. Hydration energy decreases from beryllium to barium, and hence difference of lattice energy and hydration energy becomes more and more positive beryllium sulfate to barium sulfate. Okay, consequently solubility decreases from beryllium sulfate to barium sulfate. Okay, next point, nature of bond in compounds. Nature of bond in compounds. Nature of bond in compounds. Okay, compounds in +2 state have predominantly electrovalent bond. Calcium, strontium, barium compounds are electrovalent compounds of magnesium and beryllium have a covalent character in hydrous salt like beryllium chloride and magnesium chloride, but hydrated salt are ionic. Okay, compound +2 states have predominantly. Okay, compounds in +2 states. Compounds in a +2 state have predominantly predominantly, okay, predominantly electrovalent bond, electrovalent bond, predominantly electrovalent bond, okay. Calcium, strontium, barium compounds are electrovalent. Compounds are electrovalent. Compounds are electrovalent, and compounds beryllium and magnesium have covalent character, and compounds of beryllium and magnesium, compounds of beryllium and magnesium have covalent character, have covalent character in any hydrous salt, in any hydrous salt, okay, like beryllium chloride and magnesium chloride. But hydrated salt are ionic. But hydrated salt are ionic. Hydrated salt are ionic. Okay, that is BCl2, 4H2O. Okay, that is BH2O 4 plus 2Cl negative, MgCl2 into 6H2O, that is MgH2O whole 6 plus 2 into 2Cl negative. Okay, the covalent bond character in beryllium plus 2 magnesium plus 2 arises due to greater ionic potential due to small radius mu equal to charge per radius. Okay, formation of hydration such as beryllium chloride, magnesium chloride, beryllium chloride and magnesium chloride in organic solvent, and hydrolysis of beryllium plus 2 and magnesium plus 2 evidence in support of covalent nature. Okay, anhydrous beryllium chloride is purely covalent and has the following structure. Okay, following structure: beryllium chloride BCl2, that is Be chlorine, that is Be, that is chlorine, Be, that is chlorine, and Be, that is chlorine, that is chlorine, that is Be, that is okay. Anhydrous beryllium chloride is purely covalent and has the following structures. Okay, Okay, purely covalent beryllium chloride, purely covalent, and this is the structure of beryllium chloride. Okay, next, gradation property of alkaline earth. Gradation of properties of alkaline earth metals. Gradation of properties of alkaline earth metals. Okay, gradation of properties of alkaline earth metals. Okay, first one, the reactivity increases with the increase in atomic number. Okay, reactivity increases with the increase in atomic number, with increase in atomic number, atomic number. Okay. Second point or weight. Second point, the atomic radii, ionic radii and atomic volume increases from beryllium to barium. Atomic radii, atomic radii, ionic radii, atomic radii, ionic radii and atomic volume and atomic volume increases from beryllium to barium, increases from beryllium to barium. Okay. Third point, ionization potential decreases from beryllium to barium, decreases from beryllium to barium. Fourth point, from the calcium onwards, the density increases with the increase in atomic weight. From calcium onwards, from calcium onwards, the density increases with the increase in atomic weight. With the increase in atomic weight. Okay. In atomic weight. Fifth point, electronegativity values decreases from beryllium to barium. Okay. Sixth point, the electropositivity and the reducing power. The electropositivity and reducing the electropositivity and reducing power. The electropositivity and reducing power increases from beryllium to barium. Power increases from beryllium to barium. Seventh point, as the radius of M positive increases from as the radius of M plus 2 increases from beryllium plus 2 to barium plus 2. Hydration energy decreases from and hydration energy decreases from Be plus 2 beryllium plus 2 ion to barium plus 2 ion. Okay. 9 point, Basic character of oxides and hydroxide increases with increase in atomic number. Okay. Okay. Basic character basic character of oxide basic character of oxide and hydroxides oxide and hydroxides increases with increases with increase in atomic number increase increase in atomic number. Okay. Okay. 10 point. Metallic character increases from metallic metallic character increases metallic character increases metallic character increases from beryllium to barium. 11 point. On moving down the group, thermal stability of carbonates increases. 11. Okay. Thermal stability thermal stability stability thermal stability thermal stability 1 minute. Thermal stability of hydroxides and sulfides increases. Thermal 1 minute. Thermal stability of carbonates increases. Thermal stability of carbonates thermal stability of carbonates increases on moving down the group okay, moving down the group. Okay. 12 point 12. On moving down the group, solubility of hydroxide and sulfides increases. Solubility 12 point 12. Okay. 12 point. On moving down the group thermal stability of carbonates increases on moving down the group. Okay. 12 point. On moving down the group, solubility of hydroxides on moving down the group solubility of fluoride decreases. Okay. Solubility of hydroxides solubility of hydroxides okay, solubility of hydroxides and sulfides and sulfides increases sulfides increases. Okay. 13 point on moving down the group solubility, and moving down the group, solubility of fluoride decreases. Solubility of fluoride decreases. Solubility of fluoride decreases. Okay. 14th point. The action of air, water, and dilute acid becomes more quicker on moving down the group. The action of air, water, and dilute. The action of air, water, and dilute acids become more. Dilute acid become more quicker. Okay. More quicker on moving down the group. Okay. The action of air, water, and dilute acid becomes more quicker on moving down the group. Okay. More quicker on moving down the group. Okay. 15 point. The solubility of halides. Nitrates, sulfates, and chromates decreases with increase in atomic number. Okay. Atomic number. The solubility of halides, nitrates, sulfates, and chromates decreases with increase in atomic number. Next, anomalous behavior of beryllium. Okay. Next is anomalous or abnormal behavior of beryllium. Okay. Abnormal behavior of beryllium. Abnormal behavior of beryllium. Okay. Abnormal behavior of beryllium. Okay. Abnormal behavior of beryllium. Okay. The first member of the group beryllium shows properties different from the members of this is due to following factors. Okay. This is following factors. Okay. First, small atomic and ionic radii of beryllium. First, small atomic and ionic radius of beryllium. Okay. Second point, highest electronegativity values of beryllium. Highest electronegativity of value of beryllium. Highest electronegativity value of beryllium. Third point. B does not contain B does not contain d orbital in its electronic configuration, in its electronic configuration. Okay, B does not contain d orbital in its electronic configuration. Okay, beryllium does not contain d orbital in its electronic configuration. Small atomic and ionic radius of beryllium, highest electronegativity value of beryllium. Okay, and due to radius, the first member of the group B shows property different from other members. Okay, other members. This is due to following factors. Okay, this is why the first member of the group beryllium is the first member of those group okay, is the first member of those group and shows property different from the other members and shows properties different from other members okay, of own group okay, own group. Okay, fourth point, due to small radius beryllium plus 2 ionic potential of beryllium plus 2 is high, and hence its compounds have considerable covalent character, soluble in organic solvents, salts or hydrolyzed and form hydrates. This property also extends to some extent to magnesium but are absent in calcium, strontium, barium. The following properties of beryllium are different from other members. Okay. 2 point. Due to small radius, of beryllium plus 2, due to small radius of beryllium plus 2, ionic potential of beryllium plus 2 is high. Ionic potential of beryllium plus 2 is high. Okay, and hence its compounds have considerable covalent character, and compounds have covalent character, okay, covalent character, soluble in organic solvents, soluble in organic solvents, salts are hydrolyzed and form hydrates, hydrolyte and farm hydrates. Farm hydrates. Okay, farm hydrates. Hydrolyze and farm hydrates. Okay. This property also extends some extends to magnesium but are absent in calcium, strontium, barium. Okay. Okay. This property also extends to this property. This properties also extends to this property also extends to extend to magnesium but are absent in but are absent in calcium, strontium and barium. The following properties of beryllium are different from other members. Okay. The following properties of beryllium are different from other members. Okay. First point. Beryllium compounds such as beryllium chloride are covalent. Beryllium compounds such as beryllium chloride are covalent soluble in organic solvents, soluble in organic solvents. Okay. Second point. Beryllium chloride form hydrates. Okay. One minute. Second point. Beryllium chlorides forms hydrates as BeCl2 beryllium chloride with 4H2O. Okay. Third point. Maximum covalency of beryllium is 4, other have 6. Maximum covalency of beryllium is 4. Other have 6. Okay. Fourth point. Beryllium is amphoteric. Okay. Beryllium is amphoteric. Okay. Beryllium plus 2 hydrogen chloride, that is BeCl2 plus hydrogen, and beryllium plus 2 NaOH such, that is Na2BeO2 plus H2. 6.5. Beryllium hydroxide are amphoteric. BeOH whole thrice and BeO are amphoteric. Okay, and BeX2 is Lewis acid, and forms BeX4 minus 2. Okay, 6 point. Be plus 2 salts are hydrolyzed. Okay, Be plus 2 plus H2O, that is BeOH plus H plus. Okay, 7 point. Beryllium is denser and harder. Beryllium is denser and harder than other elements due to smaller atomic size. Okay, beryllium is denser. Beryllium is denser. Beryllium is denser and harder. Beryllium is denser and harder than other. Beryllium is denser and harder than other elements due to smaller atomic size. Okay, and point number 8. Okay, 8 point. Beryllium possesses high melting point than other. Beryllium passes high melting point than other. High melting point than other. High melting point than other. Okay, 9 point. Beryllium also possesses a high melting point than other, and possesses high ionization energy than other, and high high ionization energy than other, okay, and high ionization energy than other, okay, and beryllium does not beryllium does not react beryllium does not react with water beryllium does not react with water, okay. 1 minute. Beryllium does not react with water. Beryllium does not react with water. Okay. Beryllium does not react with water while other liberates hydrogen by reacting with water, okay. 10 point it possesses less metallic character than other. It possesses less metallic character than others. Less metallic character than others, okay. And 11 point. The alkaline earth metals do not form complexes due to small atomic size of beryllium. It forms stable complexes like BeF4, okay. The alkaline earth metals do not form the alkaline earth metals do not form complexes due to small atomic size due to small atomic size of beryllium it forms stable complexes like BeF4 minus 2, okay. Next point. Next point. All the elements from magnesium to barium form ionic carbides of formula Mc2, while beryllium forms Be2C. When heated with carbon Be2, beryllium Be2C gives methane gas and reaction with water, while other gives acetylene gas. Okay. And Be2C plus 2H2O, that is 2BeO plus CH4, that is methane, and CaC2 plus 2H2O, that is C2H2 acetylene, acetylene plus CaOH whole twice. Okay. And the next point. Sulfates of beryllium are soluble in water, while those of other alkaline earth metals are sparingly soluble in water. Sparingly soluble in water. Sulfates of beryllium are soluble in water, while those those of other alkaline earth metals, alkaline earth metals, alkaline earth metals, alkaline earth metals are sparingly 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 soluble in water. Okay. Diagonal relationship diagonal relationship diagonal relation diagonal relationship of beryllium with aluminium, lithium, beryllium, boron, sodium, magnesium, and aluminium. Lithium to magnesium, and beryllium to aluminium. Okay. Diagonal relationship of beryllium to aluminium, lithium, beryllium, boron, sodium, magnesium, aluminium. That is a lithium is a relationship between magnesium and beryllium with aluminium, diagonal relationship. Okay. The radius of beryllium plus 2 is 0.67 angstrom and aluminium of 0.6 angstrom. Due to closeness in radius, beryllium and aluminium show similarity in properties. Okay. The radius of beryllium plus 2 is 0.67 angstrom, and of aluminium plus 3 is 0.6 angstrom. Due to closeness in radius, beryllium plus 2 and aluminium plus 3 show similarities in properties. Similarities in properties. Okay. First point. Beryllium chloride and aluminium chloride beryllium chloride and aluminium chloride. Beryllium chloride and aluminium chloride are covalent and have similar structure. Okay. Diagonal relationship of beryllium with aluminium. Okay. Lithium is a diagonal relationship with magnesium, and beryllium is diagonal relationship with aluminium. The radius of beryllium plus 2 is 0.67 angstrom, and of aluminium is plus 0.6 angstrom. Due to closeness in radius, beryllium plus 2 and aluminium plus 3 show similarities in properties. BeCl2 beryllium chloride and AlCl3 aluminum chloride are covalent and have similar structure okay, that is polymeric and that is dimeric, beryllium plus 2 and aluminum plus 3 form complexes that is BeF2 plus 2F negative, BeF4 negative 2, okay, AlF3 plus 3F negative, AlF6 and 3 negative. Beryllium plus 2 and aluminum plus 3 salts are hydrated. BeCl2 beryllium chloride into 4H2O and AlCl3 into 6H2O. Okay. Fourth point. Point number 4. Okay. Point number 4. Fourth one. Beryllium oxide, beryllium hydroxide, and aluminum oxide. That means alumina and aluminum hydroxide. Are amphoteric. Okay, that is Be plus 2HCl hydrochloric acid, beryllium plus hydrochloric acid, aromark of beryllium chloride, that is beryllium chloride plus hydrogen. Okay, and beryllium plus potassium hydroxide, that is K2BeO2, that means pot berylate. Okay, potassium berylate plus hydrogen gas. If we will be doing the reaction between beryllium with potassium hydroxide, then we receive as on the form of compound is a potassium berylate K2BeO2 plus hydrogen gas. Okay, and beryllium oxide plus hydrochloric acid, that is BeCl2 beryllium chloride plus H2O water. Okay, and beryllium hydroxide BeOH whole twice plus 2HCl, that is beryllium chloride BeCl2 plus water H2O water. Okay, alumina Al2O3 plus 6HCl, that is 2AlCl3 aluminum chloride plus 3H2O. Alumina is reacted with hydrogen chloride, then compound is final compound is aluminum chloride AlCl3 plus 3H2O water. Okay, and aluminum hydroxide AlOH whole thrice plus 3HCl, that is AlCl3 plus 3H2O. Okay, beryllium oxide BeO plus 2 sodium hydroxide, that is Na2BeO2. This is sodium berylate plus water. Alumina Al2O3 plus sodium hydroxide 2NaAlO2 plus H2O, that is a sodium meta aluminate, sodium meta aluminate, sodium meta aluminate, aluminate. This is sodium meta aluminate. If alumina is reacted with sodium hydroxide, then final compound then make the final compound is NaAlO2. NaAlO2. The name of NaAlO2 is sodium meta aluminate. Sodium meta aluminate. Okay. Fifth point. Fifth point. Both beryllium and aluminum are rendered passive in nitric acid. Passive in nitric acid. Okay. Both beryllium and aluminum are rendered passive in nitric acid HNO3. Nitric acid HNO3. Okay. 6 point. Beryllium plus 2 and aluminum plus 3 salts are hydrolyzed. Okay. Be plus 2 plus H2O, that is Be plus 2 plus H2O, that is BOH plus H plus. Okay. Beryllium plus OH hydroxide one negative, that is one positive is of shown of the BOH positive. Okay. And aluminum plus 3 plus H2O in the form of iron, aluminum in the form of iron Al plus 3 and reacted with water, then this is make AlOH plus 2 plus H positive ions. Okay. H positive ions. Okay. 7 point. 1.7. Beryllium chloride and aluminum chloride dissolve in organic solvent. Beryllium chloride and aluminum chloride. Beryllium chloride and aluminum chloride dissolve in organic solvents. Okay. 8 point. Point 8. Both elements react with alkali and evolve hydrogen gas. Both elements react with alkali and evolve hydrogen gas. Okay. Be plus 2NaOH, that is Na2BeO2 plus H2 2 aluminum plus 2 sodium hydroxide, that is H2O, and that is 2 NaAlO2 plus 3 H2 plus 3 H2. Okay. Aluminum reacted with sodium hydroxide and the presence of water, then the make a compound NaAlO2, sodium meta aluminate. This is sodium meta aluminate, sodium meta aluminate, okay, and 9.9, okay, point 9. Both elements react very slowly. Both both elements react very slowly. React very slowly. Very slowly with dilute hydrogen chloride and evolve hydrogen gas. Beryllium plus 2HCl hydrogen chloride, that is BeCl2 plus hydrogen gas. BaCl2 plus hydrogen gas. 2 aluminium plus 6 hydrogen chloride, that is 2AlCl3 plus 3H2, okay. Both do not decompose by action of water at 100 degrees Celsius, okay. Both do not decompose. Both do not decompose by action of water, at 100 degrees Celsius, temperature, okay. And both are stable in air because they develop an oxide film layer on their surface which protects the metal from further reactions, okay. Both are stable in air. 11 point. Both are stable in air. Both are stable in air because they develop an oxide film. They develop an oxide film layer on their surface, which protects the metal from further reaction. 12 point. The ionization potential of both the elements is almost same. Okay. That is beryllium is 6.5 electron volt and aluminium is 6.0 electron volts, okay. Summary of comparative study of group second, okay.